and welcome to the full-length presentation of my project. My project, again, was to use Terraform to create the entire AWS infrastructure to run a large-scale Drupal site, or uh, sites, if there was multiple instances of it. And this project was a lot of fun. I did enjoy it. It was a lot of work. And I'm going to walk you through everything I did here. And really, this starts again with the main file, where I've obviously provided the provider. And then one of the things to make things easier was I wanted to have a key pair loaded. So I could do that when the EC2 instance was spun up. But the overall structure of this was that, I started with defining the large pieces first. So if you look at network, you can see the very first part is the VPC, and then the gateway, and then ended up needing to create for the one public subnet for EC2 and load balancer. However, AWS requires for a load balancer 2 subnets, and they can't be in the same availability zone. So I have here one for in US East 1A, and then you come down here, and then I just created one for in US East 1B. I'm using variable substitution here. It was just easier for me to keep track of, and tags, and I tried to do tagging as much as possible as well. And then we have a route table for the public subnet, and then a gateway, and then associating that subnet with the route table, and therefore the gateway. And then a security group. I had to allow actually I ended up having to allow from anywhere SSH, HTTP, HTTPS, and what I call Pantheon, which is where the Git repository of the site was currently hosted. I needed that's port 2222. And unfortunately, because I'm on at my home internet, it can lose power sometimes, and then it resets. I didn't want to get locked out, so I had to leave ingress rules open to basically all, which I wasn't particularly thrilled about, but it was only going to be for a short time. Obviously, if I was going to maintain this in the long run, I would find a different way to do it. And then the egress rule for allowing all outbound, obviously. Then you can see here we created security groups for the load balancer, as well as some definitions of what was allowed in. I did not do HTTPS. I didn't bother generating a cert for this particular site. It wasn't. It's not live. So this is the load balancer, and also the target group for the load balancer. And that basically was the sum of the first large pieces right here. And then what happened was that I got into more specifics. So one of the things I wanted was an RDS instance. And you can see here that required, again, also that AWS requires 2 subnets, one in different availability zones. So that's what is created here. Again, a security group, ingress and egress. I'm not going to go through all that again. And a subnet. And then the instance. And I ended up going with small for this, because it wasn't a large database. And the idea was, unfortunately, one of the things that I really quickly realized was that Drupal, I could not find any information that would really allow it to scale any other way other than simply up. And it's not designed for a distributed database at all. And unfortunately, on a site where you have a lot of people logging in, even eventual consistency isn't really allowable in this instance, where if somebody creates an account, for example, and they're connected to one of the database instances, they want to be able to get logged in right away. And if it's eventual consistency, is going to be too long of a delay for any of the users to be happy about. And unfortunately, Drupal is just simply not designed to be distributed. Which was really a disappointment, because that's what I was really hoping to figure out. The next piece of this was the Elasticache. I wanted to run Redis. Drupal recommends it. At my job, we put it on every site we build. Um, it helps with the performance of the site significantly. So here again, we have two subnets because again they required it. Security groups, subnet group, ingress for Redis 6379, egress, and the Elasticache instance in the private subnet. Now, that's something I want to point out. When I built this, what I wanted was to have isolation of the Elasticache and the database instances from any traffic that might come into the site. So there's essentially um, the Drupal EC2 instances, obviously talk to the public subnet, but when they want to talk, when it needs to exchange data between that and RDS or Elasticache, there are separate subnets for each of those. And as you'll see, that was quite a challenge to implement. So the Drupal's part, I call it Drupal because it includes the EC2 instance, and also obviously I was doing quite a bit. Part of this was you had to establish network interfaces. I had one for public, one for RDS, one for Elasticache, and then I'm an Elastic IP, and then we're associating these. And this was the first place that I had a hurdle. I had thought I would go. I didn't think I could go with micro, but I thought I could get away with using a small instance to the T2 or whatever it is, and unfortunately, there's not. I actually had too many network interfaces for that tier on AWS. So I had to go up to, at the time, at first, a medium/large. I think I tried both in order to have the ability to run these three network interfaces. And that worked, and I was happy about it until I wanted to. The next piece of this, as obviously, is the EC2 instance, and I'll come right back to that in a second. But I did want to at least talk about the fact that I wanted to also do an EBS volume, and AWS now offers one that can be. It's called multi-attached, and my thinking was that the files directory for Drupal, which is really just the images, the CSS, the JavaScript, all the aggregated JS and CSS, the image styles, if we optimized images for different media, for different screen resolutions. I wanted to be able to have one volume that was shared across all of the instances. However, the IOPS is considerably more expensive. I did do it. It's only for a couple hours that I total of running it, because I was very careful to shut this thing down all the time. But the other problem did then occur when I was trying to set up the EC2 instance, because the tier you have to use in order to have the ability to do the multi-attach on the EC2 instance starts at the M5D, which is about 100 times more expensive, it seems, than the tiers I'm used to working with. This is using an Amazon Linux AMI, and you can see here I was copying some files up, including the files directory and that I was talking about, the Drupal files, as well as the database, so that I could import it, because I did not want an open connection of RDS to the public. I only wanted it on that private subnet. And this allowed me then to, SSH in and then tunnel over to the RDS instance. As well as, you can see here, to do that I had to give it some SSH creds so that I could log in. And then there was this pretty extensive user data I was doing in order to get the site set up with. It's running PHP 8.3, and I needed to install the MariaDB server so that I could have the MySQL command to connect to the MySQL instance, and then Redis. And then this is a Composer managed Drupal site, so there's that. And then Apache, and then I wanted to change the permissions so they were correct for running the site. And then here I'm if it's not formatted, the EBS volume would get formatted that first time, and then it gets attached, and at a mount point I call it Drupal files, and then essentially I'm doing everything to mount that and have that be the files directory mount point that I was telling you about. And then here's the network interfaces. So if I was the one, this was a lot of fun. I really enjoyed this project as a whole. I would be very, it was disappointing to me, the limitations of Drupal. And I will say the only other thing that I realized was that I feel like you almost have two phases with Terraform. You have the phase that I went through, which is, setting up an EC2 instance and doing all the work of getting it provisioned the way you want. But then immediately after that, because it is not really a DevOps tool in terms of code deployment, and I didn't want to take the time to move my code off of the Git repository that it's already on, the state of the code is not really dependable. If I was going to continue with this, I would, now that I have it up and running and working in Grand, I would immediately then turn around and take snapshots of RDS and snapshots of the EC2 instance and even snapshots of the Elastic Block Storage, so that I could, if I had implemented the auto scaling group, which I decided not to, frankly, because of the cost of the MD5. If I was going to do that, then I would be creating that, having it basically before it's destroyed, I'd have it create the latest snapshot and use that snapshot to create the new instance, so that at least there'd be consistency in the, along at every step. So, but you can see here, it did run. I have a VPC, I have, subnets and, route tables and internet gateway, and keep going to EC2. You can see I have the one instance here running still, and it's got several private addresses, IP4s for each of the subnets that I was talking about. If I go to RDS, you can also see here there's a Terraform named database instance. And then Elasticache as well. If I go to my dashboard here, you can see I have one cache cluster running. So, and if you look here, there's the site on it, and you can see it's it's working as expected. I mean, I didn't, it's been a while since I did anything with it, but it's up and running. It was just a demo site my company used to help develop. I think that's actually supposed to be. Oh yeah, that's not. This was we call it a demo site. It's essentially how we build, a demonstration for people of how we build sites. So, anyway, thank you very much for your time, and thanks for the semester. This was a lot of fun, and I learned a ton. So, thank you for that. All right, thank you. Bye.